Hello, welcome to Plutus IAS. So today we will discuss about the closed set. So let us see first what is the definition of closed set. Closed set. These concepts are related to the basically from limit points. So a set S is said to be closed. Let S be any subset of R. So okay, that define the uh, set S is said to be set S is said to be closed set if it contains all of its limit points. That means when any set S is said to be closed set if the given set contains all of its limit points. Okay, that means when the set is not closed, if at least one limit point of the set doesn't belong to the given set, then set is not said to be closed. For example, and we know about the limit point. What are the limit point? We have already discussed about the limit point of a set. That means any real number L belongs to R is said to be limit point of set as when if each neighborhood of L contains infinite number of elements of S. So for example, 1 upon n is a set, n belongs to n, then yes, here 0 is the limit point. 0 is the limit point. We know about it. We have already discussed about the what is the limit point and examples of the limit points. Already we have just seen about this example, that is the 0 is the limit point and so on. Finite set has no limit point. So now example, let S equal to take any set 1, 2, 3, 4. So now this is a subset of R. Obviously S is a subset of R. And what are the limit points of this set? No. This set has no limit point. So this set has no limit point. S has no limit points and therefore S is closed set. There should be no confusion about it. S has no limit point, so S is closed set. S is said to be closed if it contains all of its limit point. That means S is said to be, or you can say that S is failed to be closed set if there exists at least one point of the given set S which doesn't belong to the S. Here as S has no limit point, so obviously S is the closed set. Okay, as here there is no limit point exists which doesn't belong to the S, so S is always closed set. So every finite set, whatever the finite set, so we know, so now every finite set is a closed set. Why? Every finite set is closed set. As we know that the finite set has no limit point, and obviously if there is a no limit point such that that limit point doesn't belong to the S, so obviously the set is closed set. So every finite set is closed set as finite set has no limit points. Second, what about the Q? That is the set of rational numbers. So before to clear about the concept of closed set, we must know about the limit points. So as we have already done, so we are not going to discuss about the limit points, concept of the limit point. We will directly use the. So what are the limit points? Collection of limit point is denoted by Q dash. So what are the limit points? Set of limit points of Q. Set of limit points. Set of limit points of Q equal to complete R. We know that each real number is a limit point of the set S. So obviously obviously R is not subset of Q. That means obviously irrational number is also a limit point, and we can see that the set of limit points of Q equal to R. So Q does not contain all of its limit points, and therefore Q is not, means therefore Q does not contains all of its limit points, and therefore set of rational number is not a closed set. Set of rational number is not a closed set. Okay, bounded and closed, two different concepts. Bounded set are different thing and closed sets are different thing. Closed set, that means a set which contains all of its limit points, is called closed set, and we know about the limit point, concept of limit point. So now next, see one more example. Like suppose, what about the set of natural numbers? Set of natural numbers. So obviously the set of natural number also has no limit point. We know about it, already we have done it. So n has no limit point. We know that n has, set of natural number has no limit point. No limit point, and therefore n is also closed. N is a closed set. Okay. Must be clear that if the set has a limit point and that limit point, at least one limit point exists, and that limit point doesn't belong to the given set, then only we can say that the set is not closed. Okay, and if the set has no limit points, obviously the so definition hold, and therefore set is closed set. Similarly, set of integers is also a closed set. Every finite set is closed set. Okay, and set of rational number is not a closed set. And what about the set of real number? Is a closed set. Is a closed set. Why? Set of limit point of the set of real number is also the set of real numbers. All the real numbers are the limit point and also belong to the R, and therefore set of real number is a closed set. What about the intervals? Now what about the closed intervals? Any closed intervals? Intervals are always closed set. Always closed set. We know the limit point, collection of limit point noted as equal to, this is the notation of that, means this set is called actually derived set, that means collection of limit point of this set. Obviously also the all the points of this closed interval is also a limit points and contains, that means the closed interval contains all of limit points, and therefore closed set, a closed interval are closed set. And what about the open intervals? Suppose AB is any interval, open interval is not closed set. Not a closed set, as A and B are also the limit point, we know the limit points of the AB, limit points of AB, we know about it, that these are also the limit points, and AB both are doesn't belongs to this, means open interval doesn't contain all of its limit points. Okay, and A and B are also the limit point of the, that is end points here. A and B are also the limit point of the open interval, but A and B doesn't belong to AB. Therefore, open interval, that means the given set is doesn't contain all of its limit points. Therefore, is not a closed set. Not a closed set. So, what about the this set? 1 upon n belongs to n. Obviously, 0 is the limit point. 0 is limit point of S, but 0 doesn't belong to S, and therefore S is not closed set. As one limit point, 0 is a limit point, but 0 doesn't belong to the given set, and therefore S is not a closed set. Similarly, you can see more examples. So now you can check. Also, suppose S equal to define as minus whatever the minus 1 to the power n belongs to n. So this is a finite set. We have only two elements, finite set, and therefore is a closed set. This is a closed set. If we include in the previous example, if we include S union also 0, then the new set is a closed set, as 0 is the limit point, and in that case 0 will contain in the new set. Suppose you define the S dash equal to S union 0, so this is the closed set. This one is a closed set. So these are about the basic concept of the closed set that is related to the concept of limit point. So you must know about the limit point, then only you can be clear about the closed set. And we have seen the few examples of the closed set. So in new videos you will see about the different concept of analysis. Thank you.